I'm good to go. All right, awesome. Thank you. All right. Well, I get the great opportunity to close it all off. I think it was a really cool day, the very first cBio Portal Symposium. Um, Thank you so much to the organizers. Really cool to have to get to experience this, and um, yeah, I hope we'll do many more in the future. So I'm going to talk a bit about the cBio Portal development roadmap. So I'll get the pleasure of showing you all the cool new features that we're thinking about, and I hope that will, spark some uh, ideas in people for opportunities for collaboration. And I'll also try to talk a bit more about like how we work together, how we come up with the development plan, and actually this is really it. This is how we do it. We talk to people, and then we think, oh, maybe we should put that in the roadmap somehow. And now we just had the Hardwick discussion that maybe we should put the data in cBio portal, and that's how it starts. All right. So there's a lot of people on these slides. I think Nikki had this one as well. So, lots of different organizations, lots of different funding sources. So how do we all work together? So we basically just use Slack a lot. We talk a lot on chat, like I guess most um, software engineers, and I guess these days everybody here also uses Teams, so it's pretty common. But that's really where a lot of the communication happens. So there's a public cBio portal Slack. Anybody can jump on it, and you can ping me anytime. Then we have a community call. So that's a weekly 30 minutes call, and that's sort of open to everyone. And we usually just go over new features. So maybe if people sometimes look at the cBio portal release notes, we really just kind of go through those, and it gives sort of an opportunity for people to chime in and maybe get some explanation on what the feature exactly is for. Then we have a weekly steering committee call. So that's with all the PIs from the different institutions and the leads across the different commercial organizations. And this is really about sort of the high level discussions and decision making and sort of strategizing where to go next. And then there's a weekly sprint planning. So that's a weekly sprint with the developers that are currently working on a feature. So that's really for anybody who's sort of working on it daily. So sometimes they might be working on a feature for a few months and then they disappear again and then they come back. So that's all possible. And then we have daily stand-ups. So that's very much following sort of standard software development practices, where you sort of can talk to people and see if they have a suggestion on how to get through a particular roadblock. And then we also do a yearly spring hackathon, so that we do in New York. So if you're interested to come, you're always welcome. Drop me a line. We don't have a date yet, but usually it's somewhere around April. And we've been doing that for the past, I don't know, 5 or so years. So it will happen. Now, how do we choose what to work on? So there are really sort of, I guess, two main pillars that have stayed the same throughout the whole 17-year timeline. You have sort of this one area of precision cancer care, really focused on how do we improve sort of the clinical application of cBio portal, and how do we make precision cancer care easier. And then there's this other element of next generation cancer research. So we try to follow what are the new assays that are coming out, and how do we sort of anticipate what's going to be the new thing that people want to have access to. So those are the two pillars, I would say, that we always focus on. And the idea is to really come from a lot of different sources. So we have our mailing list, like people mail us several times a week with all kinds of requests. We do a lot of workshops, so people might sort of give suggestions. Today we got several suggestions. And there's the latest literature, so we look at what are a lot of figures that people are producing. That's maybe something that we can do in cBio portal. And then also the steering calls and the community calls. So with a lot of the ideas, it's like if you maybe hear it once, it's like, oh, that's a cool idea. But if you hear it 10 times, then you're like, hey, that's a really good idea. So if you want to see something and you think it's really important, just keep repeating it and it might happen. um, Now from idea to implementation, um, there's sort of two, I guess, rough paths. So there's when it's a very simple feature that you can maybe implement in a few days. We really just follow sort of standard open source software development flow. So people file an issue, they submit a pull request, and yeah, I think there's several people in this room actually that just started like that. There's probably, if you're a PI, there's potentially already people working in your lab who might have made some pull requests, because this is just how software engineers work today. They find some open source thing, they file a ticket, and they, sometimes they submit a PR. It's basically, how somebody who watches YouTube maybe writes a comment. This is how somebody who uses software files a ticket and maybe files a pull request. It's almost the same. It's sort of the same analogy, I would say. Now, for a complex feature where it's going to take weeks or months of work, then it's a very good idea to loop in the rest of the community and sort of try to see if it makes sense to work that much time on that feature. So then you've heard this term a couple of times. It's this request for comments, and we use a Google Doc. So I think I have an example next, but this whole idea of request for comments is not something that we came up with. It was used also, for instance, to build the internet. So people would send out requests for comments, and it's literally what it is. It's just a document, and you ask for people to comment on it, and it goes round and round until there's consensus. And that's very important in a community, that you try to build consensus. And yeah, this is for us worked as a very good way to build that type of consensus. And then eventually it will always sort of end up in GitHub issues and small tasks. But ideally try to hash out the plan first. So approximately how that goes. In the RFC phase, you sort of try to get the user needs. They're collectively transformed into a plan for improving the product. And then the core committee members, they vote on it. So as Nikki mentioned, each of the different groups working on it, they have one vote. So it's just like sort of a majority rule kind of thing. And then in the implementation phase, when the developers are working on it, it's what I sort of described, this agile process where we have weekly sprint planning and then daily stand-ups. So people are supported while they're working through a problem. And then at some point, it gets, there's sort of frequent interaction also with the product team. So once there's some sort of proposal for, hey, we have a prototype of this feature, it gets shared with the product team, they look at it, and if it all looks good, then it gets merged to production. And then there's sort of this phase also where we look, you usually encounter some more bugs. We do a lot of testing, but there's always stuff that pops up later. So then there's maybe some, post-release bugs that need to be fixed. So that's approximately the process. And then I just wanted to give you sort of two quick examples of how that works. So one is sort of a major piece of work that took very long, and then another one that's a bit smaller. So the first one is RFC 80, is really the document that describes why we wanted to introduce. Oh, sorry. Okay. So the first one is really describing why we wanted to introduce. Let me see if I can click on this link. Does that work? No. Okay. No demo views. All right. Well, so the first document introduced ClickHouse, and it was a piece of work that maybe took. We're still working on it, so over a year. We originally planned it for like 4 months. But it's as with software engineering, it's always tricky to predict exactly how long it's going to take. So after 4 months, we reconsidered and said, no, we need to spend more time on it. And so we spent a lot of time in that document sort of describing why we wanted to introduce ClickHouse. Now, the second one is maybe a bit easier to follow. So let me see. So this was really the a pairwise comparison plot. So this is a feature that the Hive developed. So they first filed an RFC to sort of describe what they were going to do. And then they built it in one pull request, basically. And the idea was to sort of allow you to connect samples in this plot. So the lines here connecting two samples. We had a few iterations in the original RFC. So people took some time to describe how it could be improved. And once we reached consensus, it was implemented. So this was actually a very smooth process. And even though it might look like a somewhat simple feature, there's actually a lot that goes into the design of it. Then, then I wanted to go over some of the accomplishments. So one thing we started to do is try to be a bit more transparent about what we're working on. And one way we're doing that is we built this about.cbioportal.org page. And this is actually a page that was also fully AI-assisted code generated. So that's something we've been also spending a lot of time with. And this is sort of the first year, actually 2025, that we were able to bring code to production that was really just written by prompting an LLM. And so this is one of the websites that was written in this way. So there's maybe a few days of prompting. Going over some of the accomplishments. So this is from last year. Just to give you an idea, there was the variant interpretation. So we added alpha missense annotations. So this. We made it easier to access plots. So now in the study view, you have the plots tab that you can look at. We added a new query and cohort building, so you can select cohorts based on specific genes, what are specific genes that are altered. We upgraded some of the dependencies. So Spring Boot is a Java dependency that we upgraded. We added ClickHouse, so that gave a performance improvement of 10-fold for Genie. We added Chromoscope in 2024, so that was very cool to see also earlier in the day that somebody was already using this. We added some genetic ancestry data for TCGA. We added mutational signatures as a feature. We added our first data set that had multiplex imaging and geomics. So that's microregion transcriptomics. And we added a lot of new studies. So 78 new studies, 65,000 new samples. We went to several conferences. We had the hackathons. We're also doing various internship programs. So if you know anybody who's interested, every year we try to participate in Google Summer of Code. This is basically a project that Google sponsors. So they'll have like a student work on open source software for 3 months. So they pay the student, they pay the organization. And I think it's a really cool project, and we've been able to actually get production code from some of those students, even only after 3 months. So I think that speaks a lot to how easy it is to get started in the code base and how easy it is to make a production contribution, that a newcomer can do that within 3 months' time. Now, I wanted to talk a bit more also about sort of, we now have a page also that outlines the roadmap, and you can click on each of these and sort of get more details about the ideas. And we're trying to work those out better and try to sort of keep them up to date as we, have our weekly steering calls. So I wanted to talk about 2 specific topics on this roadmap. So you can see there's sort of 4 categories. You have enhancements, data type support, new data, and community. So I want to talk about enhancements, so sort of a new feature for LLM integration, and then I want to talk about some of the imaging integration that we're working on. So yeah, I think particularly this year we started focusing a lot on the LLM integration, and one of the reasons was really that. So we have been working on this ClickHouse database for a while now, and they actually had some tools available that made it very easy to connect the ClickHouse database to an LLM and allow you to talk to it. And so we tried that. They had sort of some documentation set up, and basically it worked very well. So you could ask things like, what kind of data is in the cBio portal MSK cohort study? So this is one of the studies that Nikki talked about before. And it basically just does several queries. So just run SQL queries on your database and finds that study. Then it can do some things like count the samples, check what clinical attributes are available. And under the hood, it's all just SQL queries. So you can, if you understand the database structure, you can sort of look at the SQL and see if it makes sense or not. And so, then it can give you this kind of nice summary. So it can tell you, oh, there's genomic data, copy number data, structural variant data, different types of derived features. And it's pretty comprehensive. And you can imagine this was sort of out of the box. So you're like, oh, that's very promising that you get this much already without doing a whole lot of work. So just to explain a bit of the technical side of this, so the idea here is really to leverage this thing called model context protocol. And it's basically just a set of functions which allows your LLM to take certain actions. So you expose the functions to the LLM, and then it can do all kinds of stuff. But you can sort of control, with the functions, you can control exactly what it can do. And there's now lots of tools that implement this standard. It's become a bit of a standard since last year or so. So yeah, you might be familiar with like REST APIs, and this is sort of, the REST API version of LLMs. It's becoming very common. And here we use ClickHouse, but you can use any database you want. When you use, I don't know if people use ChatGPT here or see some nods. Anybody uses Claude? Okay, good. Cool. Okay, so then if you use ChatGPT and use a connector, it's sort of similar to this. So you connect it to Google Drive. It's sort of the same kind of concept. MCP came originally from Anthropic, who develops Claude. So but it became a bit more adopted by other LLM providers too. So Google uses it. ChatGPT supports it now too, and it's very widely used now. So now one challenge was, of course, how do we sort of comprehensively test the results? So a challenge with these LLMs is they can hallucinate. So how do you make sure that what it's saying is actually accurate, and how do you make sure that it gives you the same answer? So there were already some people in Nikki's lab working on this. So Michelle Waters, she had an Amazon Imagine grant, and they had developed 100 question and answer pairs that you could use for testing. So that was very convenient that we could kind of immediately leverage those. And yeah, just to give you an example, there were some questions of like, can you find all patients with an AR mutation who received leuprolide? And then, the idea is to sort of check if it gives you the correct number of patients. And we tried several of those, and it gave a good result. And you can also ask it things like, we made a few tweaks, so you can ask things like, hey, can you also show those patients in cBio portal? So if you click on a link, you can actually look at them in cBio portal and browse them. And I think that combination is very powerful, that you can in text kind of query all these very widely varying different types of queries, and then use the UI to check whether it makes sense or not, or what it gave you back is actually accurate. So I think that's a very powerful combination. that you have the flexibility, but also a way to QC the results. Yeah, so we developed some scripts to basically run this through. So we now have like 100 questions or so. And yeah, we also work with the Hive and SE4Bio to sort of expand this a bit more. So we're just sort of continuing to test this and making sure that we're getting accurate results. But overall, it looks pretty promising. Some of the challenges are when you sort of use Claude programmatically, there are some challenges around you don't know exactly what parameters they use. So in that sense, some parts of it are closed source. So that's sometimes tricky to replicate exactly the behavior. And yeah, the other part is you sort of need to update the system prompt a lot to help the database understand what it's looking at. So the process is really like you try some query, maybe the result doesn't come out, and then you update this sort of explanation of what the database looks like, and then it will get it right. And so you sort of go back and forth with that a lot. And I'm sure, over the years, this process will be improved and they'll come up with better ways to help you construct these definitions about your tables. But I am very convinced that this will work very well. And the main thing now is you have to sort of figure out how to describe to the LLM what your database looks like and what the data in your database looks like. And so, yeah, we've talked a lot about data organization, and I think, this stuff really speaks to that. Like, if we do that well, now you can just feed it to an LLM, and an LLM can understand it. And it's actually, if the human can understand it, the LLM can understand it too. So it works quite well to work together with the machines. So we have a little chat website prototype up. Don't share it too broadly. It's still very prototypey, but yeah, I'm curious. If people want to test it out and give some feedback, let me know. We're also working on sort of additional tools. So Ruslan and Gisela, they already mentioned the navigation tool as well. So sort of make it easier for people to explore cBio portal. So that's sort of in the same, LLM space, but rather than having generate SQL, it generates links within cBio portal. And then we have somebody working on sort of the publication search tool too. So you saw, for instance, the example of the MSK cohort study. Would be very cool if it could also look in the actual text of the publication and sort of give you more context, where you could ask things like, hey, I don't see this data of this study in cBio portal, but is it actually there? And maybe you could look in the article whether it exists or not. So that's sort of things we're thinking about. Yeah, and then the Hive mentioned also the LLM integration in the website. So basically allowing you to type things in. I think you would very much like this because he didn't figure out how to type the OQL syntax. So I think the user is never wrong. So it's always the tool needs to improve so that it becomes more user friendly. So we'll try to make this so you can type in this query. So I touched upon a lot of the LLM work now. So I'm actually curious. I'll maybe pause for a second, just see if that was cool. There's a question there.
Yeah, really nice to see this integration with the LLM. We were also considering it for XStat to use this model context protocol so that the LLM can get on itself the data from XStat. So it's nice to see that you got it working. So I was curious, is that LLM, where do you host it basically? Are you hosting it yourself there, or are you using some public instance?
Yeah, good question. So the LLM, we're now using Amazon Bedrock. So that basically gives you access to a lot of different LLMs. So we're not hosting it ourselves, but using Amazon service for accessing LLMs. And that's sort of within the MSK, that's considered the PHI compliant way um, using LLMs. So we've also tried to use like Anthropic, they have their own API. We've tried to use that before too. A lot of the cBio portal data is of course public, so we're sort of fine in that sense that we can use, public APIs. But for the internal data, we wanted sort of a, PHI compliant way, even though we don't have PHI data, but just to be on the safe side. So we used Bedrock there. Yeah, and maybe to add also, we did try some local models and they actually performed quite well. So I think, once we figure out the best way to describe the database structure, we'll try to sort of use different models and see if we can maybe use a local open source model or something like that to make it sort of more affordable for others to do this.
Okay, great. Thanks.
Ooh, other LLM questions. Okay, great. Then I'll switch gears a bit and talk a bit more about imaging integration and sort of how we're thinking about that, and particularly sort of how we think about adding more multimodal data analysis to cBio portal. So obviously, I think everybody here knows there's a lot of opportunity if we can just figure out a good way to combine all the data. Now, but even if we combine all the data, it's still actually quite challenging to look at it. There are actually not that many tools that are really built for looking at multimodal data. And so, of course, in cBio portal, we have sort of all the genomic data and we're sort of starting to layer things in. But we should also explore, I guess, new ways to really to view it and be able to look at all these data together, rather than just having 10 different tabs. So this was sort of a real use case that we ran into. Kevin Bohm, together with Francisco and Sarab and Nikki, he led this project where they analyzed H&E slides and genomic sequencing together from about 60,000 annotated patients, and we had 300,000 H&E images. So this is still, manuscript is still in prep, but we started to think about how can we display this in cBio portal and how can we make people interact with the data. So already today we've seen a lot of slides where people sort of showed, hey, you can add a tab on the patient view to look at this slide, but other ways that we can think about showing this data. So one thing they do in the paper is they build these multimodal embeddings. So that's sort of a dimensionality reduction concept. So I think many analysts have seen this, but just to sort of elaborate, the idea is you stick a whole lot of features into a model, and that comes up with some sort of embedding space so that whenever you get sort of a new data point, you can sort of stick it into that embedding space. And then this UMAP projection sort of allows you to basically get a 2D representation of all these different features and allows you sort of to look at it quickly. So it's very commonly used in single cell data analysis, but also any type of machine learning analysis. And so in this view, this is let me see, this is basically combining the genomic and H&E data in one sort of view, and you can see nice clustering of different cancer types. But of course, they every time got the question, hey, can you now color the UMAP by this other cancer type? Or can you color it by EGFR? Can you color it by this expression? So we started working on an embedding viewer in cBio portal, which we're calling sort of a patient map. And that allows you to explore it visually. So I don't have a video of this, but this is actually working. So if anybody wants to try it, I can send you the URL. You can color by the different cancer types. You can color by a gene. You can make selections, compare different clusters. So we sort of have a prototype of this now. and hoping to build it out further. And yeah, so let me talk a bit more about, so one other thing about this is that we were able to develop this very quickly. So this was also done using AI-assisted coding, so using Claude. And this would be a project that I think normally would take a few months, but now we could do it in a few weeks. So I think there's sort of this, that we're clearly going to be building a lot more features with the new AI tools that are now available. And I think anybody can, really. I don't think it's just limited to coders anymore. And yeah, so this is an example. So here, each dot is a patient. Each dot is a sample. But you can imagine, of course, we've seen this for single cell data too. So the next logical step is to try and see, can we also show single cell data in this way? And so that's something we're still trying to figure out. How do we pass the data in the right way? That data is much bigger. So we're currently exploring that. So then the other part is something that came up during one of the questions in Stefan's presentation. So there's really this idea of like, how do we add derived features from certain modalities? So one project we did, which is also part of my thesis, is this idea of integrating spatial profiles and cancer genomics. And we sort of applied that to identify immune-infiltrated mismatch repair proficient colorectal cancers. So here the setup was, we had H&E slides and multiplex imaging with 16 to 18 markers. We had OncoPanel from Dana-Farber. And we combined all that data into cBio portal. And the way we did that is basically we added information like cell type density as a feature into cBio portal. So each little sample gets like a fraction or a density of a particular cell type in the tumor. So that's, I guess the idea here was really like, what should these features be, and trying to come up with some sort of story that's that basically explains like, hey, this could be one, maybe other people have others. So I think this is sort of a challenge for us in the room within oncology. What kind of spatial features should we really be collecting? And I think that, if we come up with good ideas for that, that scales the data problem down a lot, because now you're only sort of working with these derived features. And ideally, for each sort of data modality, people can come up with what should be the derived features. Within genomics, of course, we sort of came up with these driver alterations, so that shrinks down your problem from 20-something thousand genes to just a few mutations in most samples. And we kind of want to come up with similar approaches here. And that's not to say it's still useful to look at sort of the lower level data, but you just want to be able to go sort of through the data at different levels of abstraction. Yeah, so this is just one of the examples that you can get out there. So one thing that you now can do is create these oncoprints that then give you also cell type marker density within the tumor. And some of the challenges around this were really sort of identifying what is tumor versus not tumor. That was all done by a pathologist. The cell phenotyping was tricky too. So that's what I've been told was sort of the challenging part of getting the data into the shape. But hopefully, as these algorithms evolve, can extract these features more quickly and get them integrated. Yeah, and so things you can do, there's, for instance, a PDL1 sample where there's a sample with a lot of PDL1 in the tumor area. And so that's something you can see here, that, oh, there's a lot of PDL1. It's a quick spot check that it's accurate. yeah, and then one thing we showed is like you can use those features then in any of the other visualizations we already have in cBio Portal. So you can say like, oh, I want to compare, infiltrated CD8 positive infiltrated tumors against low infiltration, and then one of the things we found is that it's predictive of better progression-free survival. And this is sort of a known thing, but this just allows you to reproduce it pretty quickly. So then, yeah, for the roadmap recap, so we talked a bit about the LLM integration, imaging integration. So there are a couple of other things ongoing. We're still working hard on sort of on the ClickHouse integration and really finishing it. I think the main challenge right now is that we have two databases. So we have a MySQL database that we were originally using. Currently, we switched a lot of it over to ClickHouse, but we're hoping to sort of get rid of MySQL entirely and rely on ClickHouse only to make it easier for people to install, and also reduce costs of running it. Yeah, and then we're working on some other things. There's a public curation dashboard in the works as well, allowing people to nominate studies. That's something we're working on. And then, yeah, there you see various other things. So feel free to explore it, click around, and if there's anything that's interesting, please reach out. And then I want to thank everyone here in the room for listening. I only saw a few people doze off. I mean, it's the last talk, so understandable. And hopefully we can get a bit quicker to the drinks, because I think I did it quicker.
Rob, you don't want to say anything? A question, Job.
Great stuff. I was wondering, have you looked at how the model that sort of translates the query to, well, the question to a query, how that can deal with, like, if I'm asking for wild type, where in a lot of the cases in your data, it would be NA or missing values. So if you're wanting to contrast wild type with mutated?
Yeah, that's a good question, actually. I haven't tested that type of question yet, but I will now. Yeah, it's a good idea.
So with respect to the future of cBio Portal, I think we also heard Nikki say that there's lots of ideas, but not enough resources to make all this happen. So do you have any outlook on that?
Yeah, good question. I feel it's like it would be great if we can bring in more developers into the fold. I guess that's my thought. Like I'm hoping to connect more with other software engineers and hope to pull them in. I also hope by sort of putting the roadmap out there that people see like, hey, that's a good idea. Maybe it can figure out some way to find funding for it or apply for something together. Or like they see, I think what we see a lot too is like people might implement something that we're like, hey, we're actually also really excited about it, but maybe we only see it later. And then we can't really help strategize around it and make it, more usable. So I'm hoping by, trying to be as transparent as possible as a community, we can sort of, together apply for things or come up with ways to make the platform better.
Thanks.
Maybe to add to that, if anyone has good ideas on how to bring in pharma to support cBio Portal, I think that's welcome. A long time ago, we explored with the Pistoia Alliance how to do that, but we were sort of scared by this idea that every contributing pharma company would have a seat at the table and would basically be able to tell us where to go. There must be a slightly more sort of community-friendly way to do this. Also in conversations with people at the Hive, I heard that pharma might be reluctant to pay for the development of features because they think the open source community is just going to get to those features and develop them. So maybe we have to make that clearer that as an open source community, we can't, like that we're slow. But yeah, any ideas on how we can get pharma to pitch in either directly to us or indirectly by working more with the Hive, C4Bio, etc., all be beneficial.
Currently, we are working with a consortium to react on a EU call to bring pharmas and tech companies in and to apply to the EHDS framework. And that could be a good place to bring the proposal in.
Cool.
Anyone?
Some wished for features. If you publish your study in the New England Journal of Medicine, why would people not be obliged to publish it both in a print format and in a cBioPortal format? And then if you move from the US to Europe, there's an important difference in how drugs, but also biomarkers get on the market. So in the US, you can get access the moment that for biomarkers, you can stay below $4,000 and people think it can be applied. In Europe, you need to demonstrate clinical utility. And the utility part means that you need to run these trials combined with health technology assessment. And the health technology assessment needs the data that actually could be retrieved from the cBioPortal format as well. And that could then also connect to industry that actually needs the utility to get access to the European market. So it's maybe a far leap, but I think it's an agenda that can be approached from different angles, where actually one of the selling points in the end, use real world data in systems where health technology assessment people can retrieve the right information that will allow both biomarker and pharma companies to get their products on the market. Not a straightforward funding for cBioPortal, but indirectly it could be attractive.
Yeah, that's a good point.
And thank you again,
Thank
you get your gift.
Oh,
Congrats.
thanks so much.
So colleagues, I'm tasked to give a concluding remark, and I see that some people are more active in talking, some are not. So I like to drop my task to some of you. Don't, it's a joke because I prepare my concluding remark. I just want to hear from some of you, what's your take-home message after a whole day? I will walk around and see who is looking at me. Dina, would you?
Okay, so I'm Dina Ruano. I work at Leiden University Medical Center. I'm also a clinical scientist in molecular pathology. And so what I bring home is knowing that cBioPortal can actually do something to help us, not only in research that we also do, but also in our clinical practice. That we can use it for MTBs, that will save a lot of work. We just have to figure out how. But it can be done. And that's what I bring up.
Hopefully that in our tea time discussion that could give you some step further. And I'm looking at these two ladies coming from AMC, and they work with cBioPortal via only one project. So from this day, what you would like to take home and go forward? 1 or 2 sentences.
I think it has been a while that we really worked with cBioPortal, and it for us would be good to look at all the new opportunities and also the longitudinal data, because now we made it a whole big database without any time points, so maybe we can invest in that.
So much. And the final question or final opportunity I will give to Rob, because you work in the GDI. And after a whole day, what do you think about cBioPortal and GDI?
Yeah, I think Joep gave some remarks in his talk about how the whole genome sequencing that is interested for GDI, how that would fit in and what it would require. But I took home much more. I found it really interesting to hear and to see the reactions of the rest of the people who are, of course, in research, and I'm not. I'm just support. It's a parallel universe, as we heard this morning from Gerrit. And I've seen a lot of people take pictures, so I've seen that there was a need for this symposium because it exchanged a lot of information also that the key people who organized this didn't know yet. So apparently it was a really, really good workshop also for them.
Thank you. So it's our first cBioPortal symposium, but it will not be the last one for sure. So I try to be quick and get you geared to drink. I have done my homework. So first of all, what for me I want to take home is users' need is important, and this gathering is important. For even the speakers, they told me, hey, during these sessions, I also learned some new functions I can apply. Even I'm a daily user of cBioPortal, and some colleague told me, you can even put a patient-reported outcomes in cBioPortal, and that's really the one-stop shop solution for cancer, all cancer data. I see that Hak is nodding, and we really like to optimize all the possibilities in cBioPortal to make all cancer data accessible for all. And during the tea breaks, we also talk about how to put cBioPortal also as a tool to be accepted by more institutions. So some strategic discussion, how to put the tool discussion into a broader scope, like the MTB discussion, that could be one way forward. And also, raised a very important point about how to bring patient on board and the longitudinal feature of cBioPortal, because patient knows their journey the best. And even though we try to assume their journey, there will be missing data and they need to be on board. And on European level, there are many initiatives under the ECPDC, that's the European Cancer Patient Digital Center. They are building a patient information portal, and we can work with them to bring more patients on board to cBioPortal. And last but not least, you can see I'm unbiased at all for Candle. And we like to really invite you to Candle and also the National Node of Oncology, coordinated by HealthRI and co-chaired by ICANL. So every year, 2 or 3 times in HealthRI, we organize a full day meeting, and we have 4 working groups. And one working group is really on tools, infrastructures, solutions, and cBioPortal could be a very solid recurrent topic that bring all of us there. So I will send you the invite if you like and be there with us. So finally, I'd like to thank all of you to be here with us for an exciting day. And secondly, I'd like to thank the organizing speakers, especially the speakers coming across the Atlantic, online or in person. And finally, the organizing committee, Mariska, Raymond, Gerd, Adrian, Iris, and myself. And now enjoy your drink and happy to connect afterwards. Thank you.